All right. Let's talk about expanding vaccination. So vaccination expansion was happening under the Kennedy administration. A big part of it was due to the Cold War. So Russia was giving individuals their polio vaccine for free, and the U.S. kind of wanted to not let Russia get allies, so they were trying to compete with them in the same way. They didn't want Russia to show them up in medicine and science, so they were trying to provide free vaccinations for individuals. This happened to lead to, the Kennedy administration passed what became known as the Vaccination Appropriations, plural, Act in 1961, although it ended up having some things added to it. What this did was actually frame vaccination as a legal right. So everybody had the right to health. That was part of the right to the pursuit of happiness. And so it saw vaccination as a way of doing this in order to provide for individuals. It subsidized the measles and polio vaccines. That the states purchased. So it basically provided federal funding for vaccines. In 1962, tetanus was added to this as an amendment. And then in 1965, the NIH, National Institute of Health, set up the Vaccine Development Board, which provided grants for vaccines that they thought were promising. Now, while the bill was considered popular, it did have its critics. So critics of it included some Republicans They didn't think vaccination was a right, and they shouldn't be forced or subsidized. So they didn't think the vaccines were something that everyone had a right to. I shouldn't throw all Republicans into this. It's certain Republicans viewed this. Part of the reason is that they saw that this, or they thought that this would interfere with religious freedoms. And they didn't want it to be subsidized because they thought that federal funding would mean that there would now be a pressure to vaccinate. And they probably weren't wrong in that regard. With federal funding came free vaccines, and then individuals were basically pushing other individuals that didn't want to be vaccinated because of this. When it came to talking about this, there was 3 individuals that came and spoke before Congress. One by the name of Stokes, one by the name of Adelhart, and one by the name of Miller. I'm not writing the names down because I don't think the names are important to remember. But what characterized these individuals, Stokes was a Christian Scientist. And a Christian Scientist does not just mean that they are a Christian and a scientist. It's a specific denomination. The Aldehart, he was a part of the Natural Hygiene Society. And Miller was a member of the National Health Federation. So why am I listing these guys out? Well, a few things to point out about this. Christian Scientists as a denomination really avoid most medical treatments. They believe in healing by prayer, so they would get together and pray for an individual to get better, and wouldn't actually go out and seek medical treatment. So individuals oftentimes would die because there was a life-threatening illness that they believed that they needed to pray in order for it to be healed. And if the individual wasn't healed, they kind of thought their faith was not strong enough, either the person that they were praying for or the people that were praying for that individual. So you can imagine why those individuals as a whole would be against vaccination if they were against most types of medical treatment. The Natural Hygiene Society, they were into a practice known as orthopathy, which is really a belief that fasting, dieting, and lifestyle is all that is needed for health. So you didn't really need to seek out medical treatment unless you were doing something to jeopardize your health on top of it. So they were really about natural cures and remedies to treat disease and treat and prevent. And then the National Health Federation, while it seems that they, based on the name, it sounds like a legitimate organization like the National Institutes for Health. They are really very similar to the Natural Hygiene Society. So they promoted many alternative health remedies, but were especially big into naturopathy, of which homeopathy was a big part of it. So they were very pro natural cures. Now, the criticisms that these individuals brought forth weren't necessarily not based on anything. They did actually have legitimate criticisms. First of all, the idea of circling the wagons mentality is one way that it's described by Ellen, was very much true. Individuals that were pro-vaccination didn't always look at the evidence critically and would basically not listen to criticisms of it. An example of this was with when they found the SV40 virus in the polio vaccine. There wasn't really rapid response to removing those vaccines from the general population, even though its safety was questionable. Another example of this is with the measles vaccine. Remember, they tried to create two different types. There was the killed measles vaccine and the live attenuated vaccine. Ultimately, the killed measles vaccine did not seem to be efficacious, and ultimately it appeared to actually cause problems because it could cause an allergic reaction. But the response to that was very slow because the people that were pro-vaccine didn't necessarily want to take this vaccine off the window. So in that regard, the safeguards that should have been there for vaccines, those criticisms at the time were very legitimate, that vaccine safety could have been a higher priority by the individuals. All right, so this brings us to the second part of Chapter 6, which starts with talking about mumps and then talks about rubella. So the MMR vaccine is made up of 3 different vaccines against diseases. So there's the measles, there's mumps, and there was rubella. The mumps part of the MMR vaccine was licensed in 1967. The individual that developed this was, again, Maurice Hilleman, who provides about half of our modern vaccines. What did you guys think of the story of how he isolated the virus? You guys remember that? He got it when his daughter was sick. So his daughter was sick. He left to go to the lab, get the swabs, come back, swabbed his daughter's throat, and then left and went back to the lab to store it while his daughter was not feeling very good. I mean, maybe there's more context to this, but I don't think I would feel comfortable doing that with my son, especially because I think that it said that his wife had recently passed, so he was the sole caregiver at the time, if I recall correctly. So, I mean, it would be one thing if your wife stayed there with your child while you did all this, but it sounds like he may have just left her alone. But maybe he had some sort of nanny or something. I don't know the exact context. But I think there's some criticism to be said about his priorities. But, while that may have not been the best family decision, it did lead to the creation of a vaccine that was used to treat mumps. So a few things about mumps. So of these 3, mumps was probably the least serious disease of them. Occasionally they would have some severe reactions and it would lead to deafness or meningitis, but really this was really quite rare. For most people, it just resulted in swollen glands, maybe like a fever or something that came with it, and sore throat, but then you were sick for about a week. So putting it into perspective, it really wasn't that serious of a disease. However, it was something that was kind of seen as easy picking as far as a target. So they did want to create a vaccine against it. The other member of this, so we've talked about measles. The third disease was rubella, also known as German measles. Was rubella a serious disease? If you contracted rubella, did it really cause a whole lot of problems for you? If you were pregnant, but you personally? Okay, so this was actually probably the most mild of the diseases to be infected with personally. But as you pointed out, if you were pregnant, that wasn't necessarily the case. You ended up with a minor rash, a low-grade fever, and in many cases, you may have actually been asymptomatic and not actually had any signs. However, this could lead to problems especially if you're pregnant in the first trimester. So individuals that contracted rubella while they were pregnant oftentimes would have children born with congenital rubella syndrome. Congenital just means that you're born with it. Syndrome is a disease that has multiple symptoms that are associated with it. So it's just something, a disease essentially that you're born with if you were exposed to it. So the problems, so it could lead to miscarriages in and of itself. But if you didn't have a miscarriage and were born with congenital rubella syndrome, you could have some or all of these symptoms, which would include deafness, blindness, as well as cataracts. It was associated with autism and mental deficiencies. In addition to that, individuals would oftentimes have heart problems as well. And the mental deficiencies could be quite severe in some cases, as could the autism, although there was a range of different things that could happen. Otherwise, if you were exposed to it, as I said, it was more mild. It generally tended to be less contagious than measles, but this did lead to some challenges in the development of the vaccine. So, because it was less contagious than measles, the outbreaks were less frequent. So why would that make it challenging to develop a vaccine? Sorry. Yeah. Isolating it? Well, is that what you were going to say?
Yeah, that's what I was going to say.
So not just isolating it, but what else? So let's say you've already isolated it. Okay, it makes it harder to test if you don't know when the outbreak will happen. So while a measles vaccine could be tested with a trial of 100 to 1,000 individual, you're going to need a larger trial to be certain of the efficacy of this vaccine. In addition to this, there were a few things that could occur that made it, another challenge was that it was difficult to grow, or more accurately, difficult to know if it was growing. So individuals could grow it, but it was very hard to actually detect the vaccine and determine whether the vaccine was actually there. There was about 3 people that had actually isolated this, or 3 groups that had actually isolated this vaccine about at the same time. One of the things that they did to test it, So someone found cells that would actually show something when the virus grew in them, but it actually took a lot of time for the virus to show detrimental effect in those cells. Another way of detecting the virus was by the phenomenon known as viral interference. So what was viral interference? What does it mean for something to interfere? What's that? It gets in the way. So viral interference is when one virus gets in the way of another virus growing. So viral interference allowed you to determine whether the virus was present because it would secrete a signal known as an interferon that would prevent other viruses from growing. So you could detect whether the virus was there because it would prevent other viruses that did show some sort of signal from growing in these cultures. Another challenge in sort of dealing with it, not necessarily in the development of it, was the change in the epidemiology of it. So we've heard this story before. Increased sanitation actually caused some problems with certain diseases that weren't problems before. So what did increased sanitation mean in terms of rubella?
Is it similar to polio that like the kids aren't getting exposed to it at a younger age?
So that's exactly right. So the change in epidemiology meant that the first exposure was later in life. And so you didn't necessarily have an immunity towards the rubella until you were older. And when you were older, you were more likely to be of childbearing age. And that was when you really saw problems arise. So before sanitation came along, you were exposed to the rubella virus as babies or toddlers. You maybe have a mild rash, fever, pretty much get better from it then, and have some degree of immunity then later in your life when you were of childbearing age and you didn't have these problems arise. So this epidemic of birth defects really arose after sanitation came around because of the change in when individuals were first exposed to this virus. So a few things about how rubella causes problems during pregnancy. So notice that the timing of the exposure actually would affect how severe the individual was. So if being exposed during the first trimester was more detrimental than being affected later, like towards the third trimester. And the effects that happened early on weren't necessarily the same effects that you would see later in pregnancy. You were more likely to have an autistic diagnosis if you were exposed earlier on, I think, than if you were later on. So why would that be? Why would the timing of exposure during pregnancy affect the outcome of the pregnancy?
Well,
Okay, different genes are expressed at different times. I'm looking at her because she took developmental biology with me.
The size of the child.
Okay, the size and what happens at different times during pregnancy? Do you just start off as someone that's small and get bigger? No, you have different parts that are formed at different times. So the timing of exposure during pregnancy can result in different effects. So one reason is that different genes are expressed at different times. So if you're exposed to something that is an inhibitor of a specific type of gene, but that gene is not being expressed when you're exposed to it, you might have no effect at all. Whereas if it's 2 weeks down the road and suddenly that gene is being expressed and help forming your spine or something, you might end up with spina bifida because you were inhibiting that process at that time when that gene was important. So the timing of exposure can lead to different effects due to differential gene expression during development. Although the effect of the rubella virus probably was not related to the gene expression so much as the timing of structural building. So your limbs start developing at a certain time in pregnancy, and that isn't necessarily going to be at the exact same time that your heart is developing or that your brain is developing. And so the timing of your exposure is going to matter when the critical development is actually occurring. If you're exposed to rubella when you have certain parts of the brain that could predispose you towards autism are being developed, that's going to be more likely to lead to autism than if those structures have already been developed or have yet to develop. Because if they have yet to develop, your body doesn't necessarily have those structures damaged. Another thing that can happen is with the timing is the ability of the embryo to compensate for missing parts. So the what is the phrase I'm looking for, Becca? Where the embryo has the ability to compensate for lost parts. Come on, you took my class. What's that?
Is it like a start?
Kind of. I'm drawing a blank. I'll try to remember it on Wednesday. But essentially, early the embryo has the ability to compensate for lost parts. So if you take a two-celled individual and separate those cells, you don't have an individual that just develops, you don't develop just half an individual, right? You would actually get identical twins in that situation because the embryo has the ability to compensate for those lost parts. So if you have some damage that happens early on, the embryo can actually compensate for that. If the damage happens later on, so if I split you in half, we're going to the other extreme, would you have an identical twin? No, because you have lost over time the ability to compensate for lost parts. And so the regulative development, it's related to that concept, but it has a different term associated with it. The ability of the embryo to compensate for lost parts is going to be earlier than it is, going to be greater earlier on in development than it is going to be later on in development. The later you are, the less likely you are going to be able to compensate for losing a structure within the embryo. So first 3 weeks or so, damage to the embryo will either be so severe that the embryo doesn't survive, or the embryo will be able to compensate for the damage that has happened. So very few birth defects occur due to exposure early on during pregnancy. Again, because either you don't survive, the damage is too great, or you have the ability to compensate for that. After about that 3 weeks, there is still some ability to compensate, but you start restricting that. And so damage at 7 weeks could be more detrimental than damage at 3 weeks, because now you can't compensate for that. But then you go far enough along, you are developed enough that only a small part of you is going to be damaged versus the whole part. So that is another reason why it's why you'll have different effects depending on when you are exposed. So the later they lose this ability. So you can imagine that there was a lot of sympathy for individuals that were having children with birth defects that was largely out of their control. This may have been a little bit different than individuals who have babies born with fetal alcohol syndrome, because to a degree, fetal alcohol syndrome is a choice that an individual, or is a consequence of a choice that an individual has made. Although I should make an aside, a lot of times the detrimental effects that ethanol can actually arise due to exposure before you look like you're about to say, before you even know you're pregnant. So if you or your significant other is trying to become pregnant, it might be worth noting to not be drinking while you're trying to become pregnant. And you can be supportive of your spouse if that's something that they would like you to do too. Since I'm looking directly at you, since I don't imagine you're going to become pregnant. I'm going to make, of all the people in here, I think you are the least likely to become pregnant.
That makes two of us. I think we're both equally likely.
Equally likely not to become pregnant. You know, with advances in modern science, you've seen the documentary that Arnold Schwarzenegger did, right?
No.
I don't remember what it's called, but it's a movie where they basically make him pregnant.
Oh my God.
And obviously it's not a documentary, it's a movie.
Is it supposed to be funny, or is it?
Yes, it's a comedy.
That one's funny.
Is it supposed to be funny? Yes. Is it funny? I don't remember. Lost my train of thought. So because of this, there was a lot of sympathy for individuals who were developing rubella while they were pregnant. And there was also sympathy for individuals that wanted to get abortions for this reason, because it would increase, because if you're exposed to rubella while you're pregnant, it increased the probability of having a child with severe deformities. It's always kind of hard and awkward to talk about abortion, so just if I pause every now and then, that's why. I'm just trying to be considerate of this topic. So sympathy arose for women who were exposed to rubella while pregnant, to women that were exposed to rubella and sought out abortions, and to the doctors that perform them. So in order to address this, this is part of the reason why vaccines were so important. In fact, Allen makes the argument that by creating the rubella vaccine, it actually paved the way for making abortions less palatable to the general population because it took away major justification for them. A lot of abortions were being performed due to congenital rubella syndrome and the fears that arose from it. So if we look at sort of the peak of this from 1964 to 1965, in California, there was something like about 5,000 therapeutic abortions being performed. On top of that, there was about 10,000 miscarriages. And on top of that, there was about 25,000 babies born with severe damage that you would say the congenital rubella syndrome caused severe symptoms. Because of this, this was considered a major problem, as you might imagine, with these numbers. In addition to this, sometimes there were less severe effects. About 6% of congenital rubella syndrome individuals also came with the autistic diagnosis. Why did Allen think this was notable? Or what was notable about this, according to Allen? When were you most likely to have problems with congenital rubella syndrome, exposure-wise? When the mother was exposed when? First trimester during pregnancy. So first trimester during the pregnancy, there was exposure that led to an autism diagnosis. What did that indicate? Oftentimes, or I shouldn't say oftentimes, at least in some cases, when were the foundations for autism laid down? Is the first trimester before or after birth? Before birth. So this indicated that some autistic cases, you can't say all, that would be too generalizable. You can't, just because some of them are definitively increased before this, doesn't mean you can say all of them are. Were caused or promoted before birth. So something was going on during early development that might predispose an individual to developing autism, which usually does not get diagnosed until after the first year of life, once individuals have received a few vaccines. So I think he uses this sort of as laying the foundation for the autism vaccine controversy and whether that is a valid concern. So we'll come back to this when we talk about autism and vaccines with it. All right. So the vaccine was developed by Hillman once again. He did this by putting in the virus in duck eggs. It's just noticeable. Usually they use chicken eggs, but they didn't grow in chickens. And so this was just kind of wild shot in the dark. Hey, let's try something else instead. And it actually worked to grow in duck eggs. Ultimately, the U.S. Used a vaccine strategy that was different than the UK. So what was the vaccine strategy that the US used? Who did they vaccinate? What's that? Age-wise. Who did they target for vaccination? Children. Usually it was between 1 and 4 years of age that they would receive this vaccine. Who did the UK target? Adults, specifically young women. Why did the UK target young women instead of just all children?
So it specifically causes problems with pregnancy.
Okay, so they tried to target the population that was most at risk versus trying to target everybody and stopping it before a problem could potentially arise. Which strategy was more effective? The US. USA. So this resulted in about a quarter of the cases that the US of the cases compared to the UK, even though the US had about 4 times the population. So really, they had something like 1/16 the case rate versus the UK. Now this was controversial at the time, so there's a few reasons for this. One reason that it was controversial is that you are forcing individuals to get vaccinated that aren't necessarily at risk. So making everybody get vaccinated for the benefit of society versus just trying to protect yourself is sort of a liberty argument. Who has the right? Should you have the right to walk around potentially with the rubella when the society could benefit if everybody had been vaccinated? And there was more of a scientific controversy behind this strategy as well that was kind of controversial. And that was the idea that you didn't necessarily know how long immunity would last. So this strategy, the U.S. kind of took a risk and assumed that the vaccine would produce lasting immunity that would go into adulthood, whereas the UK knew that they had received the vaccine close to the time that they would have become pregnant, and therefore should have had the immunity when they're most at risk. So it was a somewhat of a risk, but it did seem to actually pay off. Ultimately, the MMR vaccine got combined and marketed together in 1971. All right, we will pick up here on Wednesday. For Wednesday, Chapter 7. Really, I want you to read to pages 274, so from page 251 to 274, but I'm guessing I won't get quite that far based on where I got today, so if you try to get some of Chapter 7 read, but if you don't make it all the way to 274, that's fine. For Friday, read from Immune chapters 11 through 16, and then for next Monday, finish chapter 7. All right. You guys have a good day.